How electricity really reaches your home. Electricity often feels instant. A switch is flipped and light appears. But what arrives at a wall socket has already traveled through a long and complex system. To understand that journey, it helps to start with what electricity actually is. 1. What electricity really is. At its core, electricity is the movement of electric charge. In everyday power systems, that charge is carried by electrons inside metal wires. These electrons do not rush from a power plant to a home at high speed. Instead, they move slowly, passing energy along a network, much like pressure moving through a pipe filled with water. What matters is not the speed of individual electrons, but the organized flow created by electric fields. That organized movement is what powers lights, appliances, and devices. Electricity is not a substance that gets used up. It is a process, continuously generated and continuously balanced across a system. 2. How it travels from power plant to city. The journey begins at a power plant. Different plants use different energy sources, such as coal, gas, water, wind, or sunlight. But the result is the same. Large generators spin, creating electrical current. From there, the electricity enters transmission lines. Before traveling long distances, its voltage is increased dramatically using transformers. High voltage allows electricity to travel far with less energy lost as heat. This is why transmission towers stretch across landscapes, carrying power between cities and regions. These lines form long-distance highways of electricity, connecting power plants to where energy is needed. Number 3. What happens inside the grid? The electrical grid is a vast, interconnected system. It links power plants, substations, transmission lines, and local distribution networks. As electricity approaches a city, it passes through substations. Here, transformers reduce the voltage step by step. High voltage becomes medium voltage. Medium voltage becomes low voltage. By the time electricity reaches neighborhoods, it is safe enough for everyday use. Inside the grid, balance is constant. Electricity must be produced at the same moment it is consumed. If demand rises, generation increases. If demand falls, generation slows. This continuous adjustment happens across the entire grid, every second of every day. 4. Why outages happen. Power outages occur when that balance is disrupted. Storms can damage lines, trees can fall onto equipment, heat can overload components, technical failures can spread across connected systems. Sometimes outages are intentional. Sections of the grid may shut down to prevent larger damage or to protect equipment. Because the grid is interconnected, a problem in one place can affect many others. This is why small failures can sometimes lead to widespread blackouts. Restoring power means carefully rebalancing the system, not simply turning it back on. 5. Why people rarely think about it. Most of the time, the system works quietly in the background. Wires are hidden, substations are fenced off, power plants are distant. Electricity arrives silently and reliably, creating the impression that it is simple. But behind each outlet is a synchronized network operating across vast distances. Thousands of components work together to maintain a flow that is never stored, only managed. Because it usually works, it is rarely noticed, until it stops. Electricity feels immediate, but its path is anything but simple. Every light switch connects to a hidden system, constantly moving, balancing, and adapting, long before the room lights up.